Hello students, let us begin with the first session on physics problems that came in paper AIEEE 2008. Now the set of 3 questions is based on the passage which is given over here. Wave property of electrons implies that they will show diffraction effects. Davison and Germer demonstrated this by diffracting electrons from crystal. The law governing the diffraction from a crystal is obtained by requiring that electron waves reflected from the planes of the atom in a crystal and then they interfere constructively. Okay, so here you have incoming electrons. They are incident at an angle I with making angle I with the normal, and the reflection takes place at the topmost surface and let's say at a layer which is just below the topmost surface. Okay, now these two outgoing electrons, they would interfere somewhere on the screen over here. If the path difference between the two, that is this ray got reflected from here, so the path difference is between these 2 points, and if this path difference is corresponding to the wavelength, de Broglie wavelength of the electrons, then they might interfere here on the screen, right? Now let us see what the problem first has to say. Electrons accelerated by potential V are diffracted from a crystal. If D is given as 1 angstrom and angle of incidence is 30 degree, V should be about. Now the electrons which were accelerated by a potential difference V will have an energy equal to EV. Now this energy will be equal to the kinetic energy, half mv square. So if you wish to find out the momentum of the electron, that would be equal to under root of 2m ev. Okay, now de Broglie wavelength of the electron having this much of energy or having this much of momentum will be given by h by p, which can be written as h by under root of 2m ev, where v is the potential difference. Now in the given problem, the electron which is getting reflected from the topmost surface and the electron which gets reflected from the layer just below it, the path difference between the two is only this much. Okay, now this angle is given as I, this distance is given as D. So in this triangle, this is a right angle triangle, so we have D and this angle is angle of incidence, so this difference is D cos I. Now there is a path difference in the path of this electron and this electron by an amount of twice of this. So this plus this is twice of, total path difference delta x will be twice of D cos I. Okay, or you can write it as 2D cos I. Okay, now if this path difference delta x is integral multiple of the wavelength of the electron, which is de Broglie wavelength, then they may interfere constructively. Okay, so if n lambda dB is equated with h upon under root of 2m ev, h upon under root 2m ev is the de Broglie wavelength times n. Now n, h upon under root of 2m ev is equal to the path difference, which is 2d cos I. Okay, so the voltage can be written as n square h square upon 2me and 1 upon 2d cos I squared. Okay, now if you substitute the values, v is equal to n square, h square is 3.34 into 3.34 into 10 to the power minus 34 into 10 to the power minus 34 upon 2 into 9.1 into 10 to the power minus 31, that is the mass of electron, into 1.6 into 10 to the power minus 90, and 2 squared becomes 4. D squared is, D is given as 1 angstrom, so if you square 1 angstrom it will be 10 to the power minus 20, and cos square I is root 3 by 4, root 3 by 2 squared, so 3 by 4. Okay, this is cos square I is 3 by 4, so 4 will cancel out, and if we take the exponents of 10, so 10 to the power minus 68 n square, 3.34 into 3.34 into 10 to the power minus 68, and this minus 31 minus 19 becomes minus 50, and minus 50 minus 20 is minus 70, so when it comes to numerator it becomes plus 70, so these also cancel out. Now we are left with 2 into 1.6 into 9.1 into 3. Okay, now if we solve this, this will be equal to n square times somewhere 12.75. okay, if you calculate this expression, this will be somewhere close to 12.75, but among the options which are given, if we take the value of n is equal to 2, that means n square becomes 4, so 4 times 12.75 will be roughly equal to 50. So the correct answer among the 4 options that are given is 50 volts. Now the next problem related with the passage is, if a strong diffraction peak is observed when electrons are incident at an angle I from the normal to the crystal planes with distance d between them, see figure, d Broglie wavelength lambda dB of the electrons can be calculated by the relationship. So this we have just seen, the answer is 2d cos I, that is the path difference, is equal to n times lambda b. Okay, so correct option is B. This path difference, okay, this plus this is 2d cos I, and if this is equal to the integral multiple of the wavelength of electrons, then they would interfere constructively. So option B is correct. Now in an experiment, electrons are made to pass through a narrow slit of width d comparable to their d Broglie wavelength. They are detected on a screen at a distance capital D from the slit. Which of the following graph can be expected to represent the number of electrons n detected as a function of the detected position y, where y equal to 0 corresponds to the middle of the slit? So this is the central maxima position. Okay, now let us look at the options that are given. Okay, just closely look at all the options that are given. Now we know that electrons, when they pass through this slit, they will be interfering constructively at the center. Electrons reaching at the center, they will be having no path difference, so they will have a maximum. maxima, and as you move away from it, what will happen that there will be a destructive interference as well as constructive interference. So we also know that the diffraction pattern, the width of the diffraction pattern is much more than the width of the slit. Okay, so you may have, if you look at the intensity will be something like this. Okay, so here you have a minima and then a maxima. The intensity of maxima over here is lesser as compared to at the central maxima, but intensity will be found, and this width, or you can call it as fringe width, central fringe width, will be definitely more than the width of the slit. Okay, so indirectly we can say among the options that are given that the width in the case of D of the central maxima is more than that of the width of the slit. So option D is correct. Option A is also very close, but here it is given that the width is exactly equal to the width of the slit, which is not observed in diffraction pattern. The width of the central maxima is more than the width of the slit.